Section 8.3, Circles and Composite Figures. Before starting to talk about circles, we once again need to talk about some important vocabulary with circles. So first of all, let's start off talking about the word radius. Radius is the distance from the center to an outside edge. So if the blue dot represents the center, the radius is the distance from the center to an outside edge. So I'm going to label that as the radius. The circumference of the diameter, of a circle is the distance from one edge to another edge through the center. So this would be an example of the diameter. The diameter is that distance all the way through from one edge to the other through the center. Notice that the diameter then would have to be exactly twice the radius, and that will be important as we go through some work in this section. The term circumference refers to the distance around the outside of the circle. So I'm just going to go through and I am going to label this the circumference. The circumference is the distance all the way around. Some people might say it's the perimeter of a circle. In some ways you could say that, but the correct terminology for this is the circumference of a circle. Finally, we have the area of a circle. Just like area of polygons, the area of a circle is the amount of space inside that circle. One of the skills you need in this section is to be able to find the diameter if you are given the radius, or to find the radius if you're given the diameter. So here I have a circle drawn and I'm telling you that the radius of this is 6 inches. If the radius is equal to 6 inches, remember the diameter is twice that. So that must mean the diameter would be 6 times 2, or 12 inches long. If, on the other hand, let me change this for a moment, and let me use the same circle, but let me say that the diameter of this particular circle, let's say, was 17 inches. That's the diameter of that entire circle. If the diameter is 17 inches, the radius would be half of that, or 17 divided by 2. 17 divided by 2 would give me 8 1/2, or you could say 8.5. And once again, you would be saying 8.5 inches or 8.5 inches. So given one or the other, radius, diameter, you need to be able to find the one that you are not given. Another important vocabulary word associated with circles is that of pi, which is spelled P-I. You've probably heard of pi before when you talk about circles, but what is pi? Did you know that if you were to take the circumference of any circle, so the circumference once again is the distance all the way around it, and you would divide it by the diameter of the circle, the circumference of a circle divided by the diameter of a circle always gives you exactly the same number. And that number is known as pi. Now, pi is a number that goes on forever and ever. But most people just round it off to the nearest hundredth. We say pi is equal to approximately, and you can see I did not put an equal sign there, I put an approximate sign there. It's equal to approximately 3.14. As I say, it goes on forever and ever, but we just round it off to the nearest hundredth. Any circle at all that you have, if you find the circumference of the circle and divide it by the diameter of the circle, you are going to get 3.14, which is known as pi. That leads us to a very important formula that you are going to have to memorize. The circumference of a circle is pi times the diameter. Anytime that you want to find the circumference of a circle, you just need to know what the diameter is, and you need to multiply it by pi, because the diameter times pi will give you that circumference. So, if I were to say that the diameter of this circle that I have drawn right here, if I were to say that the diameter of that circle was 10 inches, I could find the circumference of that circle. I would just be multiplying the circumference is equal to pi times, in this case, 10. And I'm going to think about pi as 3.14. So I'm going to multiply 3.14 times 10. Doing that, I'm just going to have to move the decimal point one spot over to the right. So when I move it one spot over to the right, the circumference of this would be 31.4 inches. Let's use the formula, the circumference is equal to pi times the diameter, to find the circumference of this circle. But you'll notice for this circle, I didn't give you the diameter, I gave you the radius. But once again, what you need to do is you need to go through and you need to figure out the diameter. If the radius of this circle is 7 inches, that must mean that the diameter is double that, or 14 inches. So now, in order to figure out the circumference of this circle, I would just need to multiply 3.14 times 14. So I'm going to do that quickly over here to the side. 3.14 times 14. 4 times 4 gives me 16. Put down the 6, carry the 1. 4 times 1 gives me 4. Plus 1 gives me 5. 3 times 4 gives me 12. Now I need to put in my 0. 1 times 4 gives me 4. 1 times 1 gives me 1. 1 times 3 gives me 3. I add everything up and I get 4396. I just need to figure out where the decimal point goes. Remember, there's two numbers after the decimal point in the problem, so there need to be two numbers after the decimal point in the answer. So the circumference of this is 43.96 inches. So if you don't know what the diameter is, but you do know the radius, remember, you can figure that out. I should also mention to you that some books give you two different formulas for circumference. Some say it's pi times the diameter. Some say the circumference is equal to 2 pi r. I don't necessarily like that formula. You can certainly go through and use it. Just realize that 2 times the radius is equal to the diameter. It's exactly the same formula. I usually just like to use pi times the diameter for the circumference. You can use either one. Just like there is a formula for finding the circumference of a circle, there's also a formula for finding the area of a circle. The formula for the area is pi times the radius squared. So let me say that I once again have another circle, and the radius of this particular circle is 5 centimeters. If I wanted to find the area, the amount of space inside, I'm going to have to multiply pi times the radius, which is 5, squared. Remember, when you're doing this, you have to follow the rules for the order of operations. So I'm going to have to first of all figure out what is 5 squared. 5 squared means 5 times 5. So that's equal to 25. So now I would need to go through and I would multiply 3.14 times 25 to get that answer. I'm not going to take the time to go through and do the math right now for that, but I will tell you that if you multiply 3.14 times 25, you would get 78.5. Once again, because we are dealing with area, make sure that you give your answer in squares. So I would be saying it's 78.5 square centimeters for the final answer of this. Let's do one more example. Here I have a circle, and I'm giving you the diameter of the circle. I'm telling you that the diameter is 16 centimeters. First of all, let's just find the circumference. In order to find the circumference, I'm going to multiply pi 3.14 times that diameter of 16. Once again, I'm not going to go through and do the math here, but if I did go through and do the math, I would find that 3.14 times 16 gives me 50.24, and that answer is just going to be in centimeters because I just want the distance around the circle. To find the area is pi times the radius squared. Well, if the diameter is 16, that means the radius has to be half of that, or 8. So my area is going to be 3.14, which is pi times 8 squared. 8 squared means 8 times 8, which is 64. So now I have 3.14 times 64. Once again, if you go through and do that math, you will get 200.96, and I'm going to have to give my answer in square centimeters. So the area of the circle would be 200.96 square centimeters. Another idea talked about in this section is finding the perimeter and area of what is known as composite figures. A composite figure is a figure formed by adjoining two or more basic geometric figures together. So you can see that I have done that, and I have a lot of different measurements in here. If I wanted to find the perimeter of this particular figure, remember, perimeter is the distance all the way around, and I have most of the lengths of the sides labeled. But there are two of them I don't have labeled. I don't have the measurement of this side, nor do I have the measurement of that side. But given the information in the problem, I can figure out the distances of those sides. First of all, let's talk about the one up at the very top. I know that the bottom distance is 10, and I know that this distance from here to here is 7. That must mean that that distance that I'm missing right there must be 3 feet. It must be 3 feet because 7 plus the 3 would give me 10. The same holds true for the other question mark that I have. In the other question mark, I know that this distance from here to here is 10, and I know this distance from here to here is 7. So once again, that must mean that this question mark is also 3 feet. Now I know the distance of everything, and I could just go through and I could add all those numbers up. So I'm going to go through and do that for a moment. I'm going to start with this right here, and I'm going to go this way, going all the way around that figure. So I would be adding 10 plus another 10 plus that 3, that distance that I just found, plus another 3, plus a 7, plus a 7, and then I would add all those numbers up. So just doing that, 10 plus 10 gives me 20. Oh, I notice I have a 3 and a 7 here, which gives me 10. I notice I have another 3 and another 7, which gives me 10. So 20 plus 10 plus 10 gives me 40. So I know the perimeter of that particular figure is 40 feet. One other thing I would like to mention to you that you could have done with this. Notice that if I had just decided to take this red line that's right here and moved it over to here, gotten rid of it then, and moved this red line right here, moved it up to here, then, and gotten rid of that, I would have had exactly the same thing. But I would have had a square that was 10 feet by 10 feet. And a square that is 10 feet by 10 feet has a perimeter of 40 feet. You don't have to do it that way. You can just go through and do what I did first to figure out the missing lengths and then add everything together to find the perimeter of a composite figure. Here's another composite figure. But this time, rather than finding the perimeter, we're going to work on finding the area. In order to find the area, I'm going to break this figure up into a couple of different figures that I'm more familiar with. So I'm going to draw a dashed line here. So what I did is I divided that figure up into two different rectangles. And now I'm going to work on finding the area of each one of these rectangles. Let me find the area of this top rectangle. I just put a big dot in the middle of it. I know that the one side of that rectangle is 20 feet. I don't necessarily know the distance, the height of that particular rectangle, because 8 feet is the entire height of that composite figure that I started with. But I do know that this distance from here to here is 2 feet, and that this distance from here to here is 8 feet, which means that this must be 6 feet long. So the area of that top rectangle, which is 20 by 6, must be 120 square feet. And I'm going to write that in there. Now I need to figure out the area of the smaller one. The area of the smaller one, it's a rectangle that's 15 feet by 2 feet. 15 feet by 2 feet is 30 square feet. So now I can add those two numbers together. 120 plus 30 gives me a final answer of 150 square feet for the area of that. Once again, I need to find some missing numbers, and then I break it up into areas of parallelograms that I know how to find the answer to and put everything together. Here's another composite figure, and I did my best to draw a perfect half circle on the top of this. It's actually a rectangle, the shaded in part. It's 10 by 9, and I need to be able to find the area of this composite figure. I also need to be able to find the distance around this composite figure. So let's first of all work on finding the area of this figure. I know that the area of just that rectangle, it's 10 by 9, the area of that rectangle is 90 square feet, because I'm just going to multiply 10 times 9. Now I need to find the area of that half circle. Once again, to find the area of a circle, it's pi times the radius squared. Well, if the distance across the center of the circle is 10 feet, that must mean that the radius is 5 feet. So I'm going to multiply pi times 5 squared. 5 squared gives me 25, so I have pi times 25. And once again, if I go through and figure out what is pi times 25, I am going to get 78.5 square feet. So the area of this half circle would not be 78.5 square feet, because that would be the area of an entire circle. I'm going to have to go through and I'm going to have to divide that answer by 2, because I have half of a circle. If I take 78.5 and divide it by 2, I'm going to get 39.25 square feet. So the area of that half circle is 39.25 square feet, which then I'm going to add to my 90 square feet. So 90 plus that 39.25 square feet gives me a final answer of 129.25 square feet. Let's use the same figure and this time find the distance all the way around it. So in order to find the distance all the way around it, it's easy to find the distance around the rectangular part. 9 plus 10 plus 9. 9 plus 9 gives me 18, plus the 10 gives me 28. So I know it's 28 feet just around the rectangular part of my figure. Now I need to find the distance around this half circle. I'm going to use the circumference formula. Circumference is pi times the diameter. The diameter of that is 10 feet. So it would be pi times 10. Pi is 3.14 times 10, so it would be 31.4. But once again, I only have half a circle, so I need to divide that 31.4, I need to divide that by 2. 31.4 divided by 2 gives me 15.7. So this distance is 15.7 that I need to add to the 28 feet that I have altogether, giving me a final answer of 43.7 feet. Let's do one more example. Here I have a square that is 12 inches by 12 inches and a circle with a diameter of 12 inches. And I want you to find the area of the shaded in sections, those 4 different corner sections. In order to do that, what I'm going to do is I'm going to first of all figure out, well, what would be the area of the square if I was just wanted to know the area of the entire square? Well, that would be 12 by 12, which would be 144 square inches. If I figure out what the area is of the circle, I could go through and I could subtract out the area of the circle, and then I would know how much I have left for the shaded part. So the area of a circle, once again, is pi times the radius squared. If the diameter of the circle is 12 inches, that means that the radius is 6 inches. So I'm going to have pi times 6 squared. 6 squared gives me 36. So I have 3.14 times 36. If you do the math, 3.14 times 36, that's going to give you 113.04 square inches. Now, I know that the area, as I said before, of the entire square is 144 square inches, so I am just going to go through and subtract 144 minus 113.04. I would get a final answer of 30.96 square inches. So, the area of the blackened in area, each one of those corners, if you will, of that square, they must total 30.96 square inches. In order to be successful in this section when taking the test, you do need to know these formulas. You need to know that the circumference is equal to pi times the diameter. You also need to know that the area is equal to pi times the radius squared. Remember, you are always going to be using 3.14 for an approximation for pi. As always, if there's anything I can do to help you as you work through this section, please let me know. Thank you.